Alright, in the last lecture of this section, I have combined all transactions that we have performed on binary heap to see the time and space complexities of these transactions. So this time and space complexity is applicable for array implementation. Now the first transaction is creating binary heap. So when we are creating a binary heap in case of array implementation, we are just declaring an array in the memory and we are just initializing it with the given size. Now in this case, initializing an array in the memory will take O1 time complexity, so that's why creating binary heap will take O1 time complexity. Now the space complexity in this case On, because whenever we are creating binary heap using array implementation, in this case we are creating n number of contiguous cells in the memory. So that's why even if we have not inserted any elements to this array over here, it takes space in the memory, so that's why the space complexity is On. Now then, the next method is pick of heap. So whenever we are calling a pick of heap, it's just returning the value of root node from the heap. So in case of array implementation, we know that the value of root node is always located at the index of 1. So accessing an element in the array with given index takes O1 time complexity. So that's why pick method over here will take O1 time complexity. Now similarly, the space complexity is also O1 because in this case, we have not performed any space consuming operation. Now the next method is size of heap. So whenever we are creating a heap class, we are declaring a variable over here which stores the size of heap. So in this case, whenever we are inserting a new element to the binary heap, we are increasing this size, and whenever we are extracting an element from the binary heap, we are decreasing this size. So in this case, whenever we are calling size of heap, we are just accessing this variable and returning the value that we have in this variable. So this operation will take O1 time complexity, and the space complexity is also O1 because here again we have not performed any space consuming operation. Now the next method is traversal of heap. Now whenever we are traversing any given data structure, we are visiting all nodes of this data structure. So in case of binary heap, this is also same. Here, when we are traversing through the binary heap, we are visiting all nodes of binary heap and printing out their values to the console. So this means that if the number of nodes in the binary heap is n, so the time complexity will be On. Now in this case, we are just looping through the array, so that's why the space complexity is O1, because in this case, we are not creating any additional data structure to traverse, and we are not using any stack memory because we have not called any recursive calls over here. So that's why the space complexity is O1. Now the next method is inserting a node to the binary heap. So we know that in case of binary heap, whenever we are inserting a node to the binary heap, we are inserting it to the next vacant place. But after inserting, there might be cases that this new inserted node causes violation of binary heap properties. So in this case, we are calling heapify method for binary heap. So this means that when we are calling heapify method, we are going to call it recursively, either for right child or left child. So this means that it will take all again time complexity. So whenever we are calling a method recursively, so this means that we are inserting elements to the stack memory. So that's why the space complexity also for this operation will be all again. Now the next method is extracting a node from binary heap. So as we mentioned before, whenever we are extracting a node from the binary heap, we can just extract the root node. So when we extract the root node from binary heap, we have to replace root with the other element. So what we are doing over here is we are taking the last element from the binary heap and replace it with the root value. Now after replacement, here again, the property of binary heap might be violated. So in this case, to prevent these cases, we are going to call heapify method to do some adjustments in binary heap. So this means that calling heapify method will take all again time complexity. So that's why extracting a node from binary heap in the worst case will take all again time complexity. So here again, the space complexity is all again because in this case also whenever we are calling heapify method, the heapify method calls itself recursively for either left or right child. So this means that it will be all again space complexity. Now at the end, deleting entire binary heap. So whenever we are deleting entire binary heap, in case of array implementation, we are just setting array to null. So whenever we are setting array to null, it's going to delete this array from the memory, and all elements of the binary heap will be deleted from the memory. So this means that this operation over here is O1 time complexity because here we are just doing simple assignment statement. And the space complexity is also O1 because in this case we are deleting everything from the space. So this means that it will take O1 space complexity. Now with this we have come to the end of this lecture. So in this lecture I have combined all binary heap transactions that we discussed in this section together to see the big picture of time and space complexity. So hopefully everything is clear about this. So with this lecture we have come to the end of binary heap section. So hopefully everything is clear about binary heap also. So see you in the next section.